So welcome to our third session together. This week we will be looking at excess calculations. These are calculations where you look at what reactants there's too much of and which reactants are limiting how much product we can make. So by the end of this session you should be able to use your balanced equations and mole calculations to work out which reactant is in excess and which is limiting. And you should also note that sometimes to ensure that a costly reactant is converted into product, we can use an excess of a less expensive reactant to make sure that the expensive reactant, costly reactant, is converted into the product.
So today I'm going to bake some cakes, and I want to make lots of fairy cakes, cupcakes you might call them, and I've got plenty of some ingredients. I've got plenty of margarine. This is a 500 gram tub and most of it's still there. To make 12 cakes I need 125 grams, so I've got at least 4 times that amount, so I've got enough of the marg to make 48 cakes. Also need 125 grams of flour for 12 cakes. If I want to make the 48 cakes like I can make with all the marg I've got. 500 grams of flour. Oh, I've got 1.5 kilos. More than enough. 125 grams of sugar needed, and I've got 500 grams here. Again, I've got plenty, not just to make the 12 cakes, but to make 48 cakes. Loads of cakes. For 12 cakes, I need 2 eggs. To make 48 cakes, I'm going to need 8 eggs. I don't have that, so I'm feeling a bit sad. The eggs are limiting the number of cakes I can make. I've got an excess of all my other ingredients, but the eggs limit what I can make in the end. And that's the idea of excess and limiting reactants. We often have more than enough of some of the things going into our chemical reaction, but there'll always be one chemical that limits what we can make. And our goal is to use our mole calculations and mole ratios in our balanced equation to figure out which is limiting and which is in excess.
So here's the finished product. The eggs were limiting, they've all gone. I still have some of all the remaining ingredients. They were in excess, I have leftover of them. I was only able to make the 12 cakes because the eggs limited what I could make, even though there was excess of everything else. So we'll look at some examples of excess calculations now. There are many different ways to set out these calculations. Your own teacher may have a particular way of doing it, and if you find that way easier, go with that. We're just going to be showing you one of the possible ways to lay it out. Methyl cinnamate is an ester used to add strawberry flavour to foods. It's a naturally occurring ester found in essential oil extracted from the leaves of strawberry gum trees. This is what we call the stem of the question. It sets the scene, but it's not really helping us with the task we have to do, so I've just scrolled that out the way. A student prepared a sample of methyl cinnamate from cinnamic acid and methanol, and they've got an equation here for us. They're not using formula because some of the formula for this are quite complex. They're just using a word equation, and they've given you the gram formula mass as well, so that's there for you. They say here that 6.5 grams of the cinnamic acid was reacted with 2.0 grams of the methanol. Show by calculation that cinnamic acid is a limiting reactant, and they're giving us the mole ratio here. 1 mole of the acid reacts with 1 mole of methanol. Our very first step is going to be to focus in on the reactants and calculate how many moles of them we actually have. and you'll get one of the 2 marks that are available for calculating the moles. So for the cinnamic acid, we've got 6.5 grams divided by the mass of 1 mole, the GFM 148, and that gives us 0.044 moles. Now I've rounded this to 2 sig figs because in the question the maximum number of sig figs there are is 3, but we always round to the minimum number of sig figs we've got, and that was 2. So I've rounded to 2 sig figs. So same as before with methanol, mass divided by GFM, and again we're round to 2 sig figs, gives us 0.063 moles here. Our next step is to look at the mole ratio of these two and figure out how much of each one is needed. We're told in the question that the mole ratio is 1 to 1. 1 mole of cinnamic acid reacts with 1 mole of methanol. We've got 0.044 moles of the cinnamic acid. So it needs 0.044 moles of methanol. When we look at our calculations, we see that actually we've got far more methanol than that. We've got 0.063 moles of methanol. So that tells us that there's extra methanol, more methanol than we need. So we can say the methanol is in excess. You should always finish your answer with a little statement summing up what you found, explaining which reactant is in excess, which is limiting, and why that is. So this question's worth 2 marks. Your first mark is for calculating the moles of both reactants. Your second mark is for using the mole ratio to show which one is in excess and which one is limiting, and giving an explanation of this. 0.40 grams of sodium sulfite, Na2SO3, is reacted with 50 centimetres cubed of dilute hydrochloric acid, concentration 1.0 moles per litre. And we've got a balanced equation here, and they've given us the gram formula mass of the sodium sulfite there. Show by calculation that sodium sulfite is a limiting reactant. Well, we're just interested in the reactants, comparing the reactants to each other, so we're going to just block out these products here just now so we're not distracted. So step 1, as before, calculate moles of reactants. There's very few chemical calculations where you don't start by calculating moles of reactants. And if you're not sure where to start a question, if you can calculate moles, calculate moles. Now I always advise students to take highlighters into the exam, because then you can highlight things and make sure you've got the right data with the right chemicals. So we're told that sodium sulfite is Na2SO3. So I'm going to highlight that in one colour. And this 0.40 grams belongs to sodium sulfite as well. Hydrochloric acid is my other reactant, and I'm going to carefully read through this and just highlight what's related to the hydrochloric acid. So when I go to do my mole calculations now, things are clear for me. I'm not sifting through the wordiness and the details of the question. I've just taken a moment at the start to get that information straight. So I've gone ahead and substituted the numbers into the equations, and I've got my moles calculated. I have converted the 50 centimetres cubed of hydrochloric acid into litres, 0.05 litres. I have 2 sig figs here, so even though I've got 4 sig figs here, my answer is limited to 2 sig figs. So I've just rounded my moles of sodium sulfite to 2 sig figs here. Our second step is we are going to compare the moles of the reactants using the mole ratio from the equation. So our mole ratio is 1 to 2. So I've taken the moles of the sodium sulfite that we calculated. and I've said, well, if I've got one of that, I'll need twice as many moles of the hydrochloric acid to react, so 2 times 0.0032 gives us 0.0064 moles. Let's check back to our hydrochloric acid here. We've got 0.05 moles and it's 0.0064 moles we need. So we've got nearly 10 times as much hydrochloric acid as we need. That tells us that the hydrochloric acid is in excess, whereas the sodium sulfite is limiting. And now we need to finish up with a wee sentence saying that. So I'll recap the steps again. First step, you calculate the moles of both reactants. Second step, you use the mole ratios, what we call the stoichiometry, to compare the moles of the reactants and see if we've got this much sodium sulfite, how much of the hydrochloric acid do we actually need? And then we look back at what we actually have. Do we have more than that? Do we have less than that? And that tells us which is limiting and which is in excess. And you give a wee summary statement at the end saying what you found. So we have one from 2018 here, chemical reaction in an experiment as shown below. We've got benzoic acid reacting with methanol to make methyl benzoate. And here is our equation here. And they've already given us the gram formula masses there for us. In a lab experiment, a student used 5.0 grams of benzoic acid and 2.5 grams of methanol to produce the methyl benzoate. And you have to explain why benzoic acid is a limiting reactant. Now, as before, I've just cleared the products so we're not distracted by them. And like I did in the last question, we're just going to highlight a few things to keep us right with which quantities belong to which reactant. So there we go. So now when I'm putting things in my calculations, it's easy for me to pinpoint what belongs with what. So step one for your first mark is mole calculations, and we've got that there, just substituted the numbers in, and I've stuck with 2 sig figs in my answers because of the 2 sig figs here. We do have 1 to 3 sig figs, but we go with the lowest number of sig figs. On to step 2, where we're going to be using the mole ratio from the balanced equation to compare the number of moles we calculated. So with 0.041 moles of benzoic acid and using the mole ratio for all that benzoic acid to react, we need 0.041 moles of methanol. Now we check back to what we have of methanol and we see there is much more methanol than what we need. That tells us that the methanol is in excess, whereas the benzoic acid is limiting. So the final step is our statement, just summing up what we've found. Occasionally excess comes up in the multi-choice, and we're going to look at 2 examples of that now. The clues that this is an excess calculation, we have limiting and excess in 2 of the possibilities for our answers, and that's our clue there. We're just going to tackle this exact same way as we did with the longer questions. I'm going to find things that are connected. So that's all the information about calcium carbonate. Here's some nitric acid information here. And they've given us some information about carbon dioxide. Now we haven't covered molar volumes of gases with you yet. That's coming up next lesson. You may have covered that with your own teacher already. We'll just work our way through the question and we'll deal with that if we need to. Now multi-choice are worth 1 mark. That means you get 1.5 minutes allocated for answering this question. There's a lot to do. They've tried to keep the numbers simple to help you get through it quickly. So carrying out the mole calculations, we can see that there's the same number of moles of each reactant. We need to go to step 2 and compare the quantities using the mole ratio now. So there was 0.02 moles of each of the reactants. So if we go with our calcium carbonate first and we say our mole ratio is 1 to 2, this is from the balanced equation. So for 0.02 moles of the calcium carbonate to react, we need 0.04 moles of nitric acid. We don't have that. Not all of this calcium carbonate will react because it's been limited by the amount of moles of the nitric acid that are there. So the nitric acid is limiting, the calcium carbonate is in excess. So straight away we can say A is wrong. Calcium carbonate is a limiting reactant. No, it's not. The nitric acid is. It also rules out B. If nitric acid is limiting, all the nitric acid is going to be used up in the reaction. There can't be an excess of nitric acid then. The limiting reactant will be used up. That takes us on to the next two options, and both of them are about what is produced in the reaction. So we'll start with the calcium nitrate. How much is produced in the reaction? Using the nitric acid moles, I've just worked out using the mole ratio that 0.01 moles of calcium carbonate should react. So I'm going to pop these up beside the balanced equation. So we have a mole ratio of 1 to 2, and we've seen that 0.02 moles will react with 0.01 moles of the calcium carbonate, and there'll be excess calcium carbonate left over. Calcium carbonate is in 1-to-1 ratio with the calcium nitrate. So 0.01 moles of this reacts, then we should get 0.01 moles of the calcium nitrate. We've got the mass of 1 mole as 1.64 grams, and so we know that the mass of 0.01 moles is 1.64 grams. Now it's worthwhile just pausing the video and double checking that for yourself to make sure you're understanding where these numbers come from. But 1.64 grams is produced, and that means the answer C is correct. In our final example here, it's another multi-choice. They've made it slightly easier for you because they've already calculated the moles for you, and you're really just using the mole ratio to see which one is in excess. So step 1, calculating the moles, is done already. This allows us to move straight on to step 2, looking at the mole ratios. So the mole ratio given is 1 to 2. So for all the 0.05 moles of magnesium carbonate to react, it needs twice as much nitric acid, which is 0.1 moles. The question says we've only got 0.06 moles, so there's not enough nitric acid, not enough for all this to react. So that tells us that the nitric acid is limiting. So just like the eggs controlled how many cakes I could make, they limited the cakes I could make. Because the nitric acid is limiting, it's going to control what is made in this reaction. So 0.06 moles of nitric acid reacting, half as much of the magnesium carbonate will react. Magnesium carbonate is in 1-to-1 molar ratio with magnesium nitrate, as are the rest of the products, so I can fill in the moles for them as well. So 0.06 moles of nitric acid reacts with 0.03 moles of magnesium carbonate to make 0.03 moles of magnesium nitrate, 0.03 moles of water, 0.03 moles of carbon dioxide. So straight away we can rule out a few things in the answers here. 0.05 moles of carbon dioxide is produced. No, that's wrong. 0.03 moles is produced, so let's score that one out. 0.06 moles of magnesium nitrate is produced. No, it's 1:1 with the magnesium carbonate, so that's 0.03, so that one's wrong as well. Magnesium carbonate is in excess by 0.02 moles. Well, we know it's in excess. Is it in excess that much? We'll figure that out in a second if we need to. Let's check the last one. Nitric acid is in excess. We can stop there. That's wrong as well. We know the nitric acid is limiting. So the answer has to be C. We can just check that over. So from the question we know we have 0.05 moles of magnesium carbonate. We've worked out that we're using 0.03 moles of the magnesium carbonate. That means left over with 0.02 moles in excess. And that does indeed fit with answer C. So we can calculate which reactant is in excess, but excess can also be useful when we purposefully want to calculate how much of a reactant we want to put in excess. For example, here we've got silver nitrate and reacting with sodium chloride to give us a silver chloride precipitate, and sodium nitrate salt is also produced. Silver nitrate is a lot more expensive than sodium chloride. So if we are using silver nitrate, we want to make sure it all reacts. And to give you an idea of comparison of the prices, we can get a kilo of sodium chloride for £30, but a kilo of silver nitrate is going to be £3,030. It's a lot more expensive. So if we're using the silver nitrate, we need to make sure it all reacts. And one way for us to do that is to put an excess in of the much cheaper chemical to ensure that reacts. So I've gone over some examples of the excess calculations with you in this video. There are some questions for you to try yourself. Just make sure you follow both steps through. And the other thing you need to know that we've just been talking about is that to ensure a costly reactant is converted into product, an excess of the less expensive reactant can be used. If anything is unclear or you want us to go over some of the questions in particular that we've set you, please fill in the Microsoft forms so we know what to cover with you in the webinar.